Have you ever wondered what makes a lemon so sour it makes you pucker up? Or what's actually going on in an ant sting that makes it hurt so much? Well, it turns out they have a surprising chemical connection. Let's get into it.
All right, let's jump right in with a bit of a puzzle. It connects two things you've probably never, ever thought to put in the same sentence before. So here's the big question. What on earth could the sharp bite of vinegar possibly have in common with the sting of an ant? I know it sounds totally random, but there's a really fascinating chemical link hiding in there.
But then, when you throw things like citrus fruits and even sour milk into the mix, a pattern starts to show up, right? All of these things have that same kind of sharp, sour, or stinging quality. And the reason why is exactly the same for all of them.
The answer to our little mystery? It's a whole family of chemical compounds called carboxylic acids. You can think of them as the invisible architects behind all of those sensations we know so well.
So what are they exactly? Well, a carboxylic acid is basically an organic compound that has this very special feature, a little piece of it called the carboxyl functional group. We just write it as -COOH. This little group is the active ingredient, the part that gives these guys their signature sour taste and all their acidic properties.
And how does this carboxyl group get its special powers? It's actually a team-up. It's a combination of two other groups, a carbonyl group and a hydroxyl group. When they join forces on the same carbon atom, they create that powerhouse COOH group, and it gives the molecule a completely new chemical identity.
Okay, so how do chemists tell all these different acids apart? Well, thankfully, they came up with a beautifully simple and logical system for naming them. Let's take a look at the blueprint. It's a super simple three-step recipe. You just start with the name of the base carbon chain. Let's use ethane as an example. You just chop off that final E, and then you add the suffix oic acid. And just like that, ethane becomes ethanoic acid. Simple, right? And you can see the pattern plain as day right here. Methane gives you methanoic acid. Ethane gives you ethanoic acid. Propane becomes propanoic acid, and so on. This system is so predictable, it makes it really easy to figure out an acid's structure just by hearing its name.
Okay, so now we know what they are and how to name them. But what do they actually do? Let's explore their personality a bit, how they behave chemically, their attitude, if you will.
Now, this is a really crucial point. Carboxylic acids are what we call weak acids. But don't let that word weak fool you, okay? It doesn't mean they're not powerful. It just means that when you put them in water, they don't completely fall apart. They only release some of their hydrogen ions, and that's the key to how they react with everything else.
And they have four main ways they like to react. They'll go at it with metals, with bases, with carbonates, and with alcohols. Let's take a quick look at what happens with each one. When one of these feisty acids meets up with a reactive metal, you get a pretty lively reaction. It'll produce a salt and some hydrogen gas. But when it meets a base, it's a totally different story. It kind of just calms down. That's a classic neutralization reaction, and you're just left with a salt and plain old water.
Now their reaction with carbonates, think baking soda, is one you've definitely seen before. You get a salt, you get water, and you get that unmistakable fizz of carbon dioxide gas. Yep, this is the exact same reaction that makes those volcano science projects erupt.
But maybe the most creative reaction of all is something called esterification. This is when a carboxylic acid reacts with an alcohol, and the result is a whole new compound called an ester. And this is where things get really fragrant. Esters are the molecules responsible for so many of the world's most pleasant, fruity, and sweet smells. They're used in everything from perfumes to food flavorings.
So let's zoom out now and connect all this chemistry back to the real world. We've gone from the tiny molecular level all the way to things we can actually see, taste, and smell every single day.
Let's just lock in on 4 key examples of these acids that are pretty much hiding in plain sight all around us.
Let's finally connect all those dots from the beginning. That ant sting, that's methanoic acid. The main ingredient in vinegar, that's ethanoic acid. The sour power in lemons, you can thank citric acid. And lactic acid, now this is really cool, that's what gives yogurt its tang, and it is the exact same molecule that makes your muscles burn after a tough workout. It's chemistry connecting your fridge to your fitness. And if we take a closer look at just one of these, ethanoic acid, we see how important it is. It's not just for putting on salads. Its acidic nature makes it an absolutely fantastic food preservative because it stops bacteria from growing. And this just goes to show how vital these compounds are.
I mean, from the scents in perfumes to making soaps, plastics, and even life-saving medicines, carboxylic acids are true workhorse molecules in tons of industries.
So I'll leave you with this question to chew on. After everything we've just covered, what common things in your life are powered by these amazing little acids? I guarantee the more you look, the more you're going to find them. Thanks for tuning in.